For decades, artificial intelligence advanced under direct human supervision. That era is ending. AI development is shifting towards autonomous, agentic systems, executing recursive self-improvement, algorithms writing and refining their own successors at the speed of compute. Historically, we have attempted to align these systems through classical epistemology. We design them to be truth-seeking, requiring models to form accurate one-to-one representations of a mind-independent reality. At the scale of artificial superintelligence, or ASI, exhaustive searches for absolute truth exceed any feasible computational budget. The information space is simply too complex to map perfectly. Signal corruption compounds the issue. As systems ingest massive, unfiltered data streams, the noise-to-signal ratio spikes, making the distinction between truth and synthetic artifact undecidable. This creates systemic fragility. When coupled feedback loops approach critical thresholds, the time required to accurately model the environment far exceeds the time available to take evasive action. Aligning an ASI to objective truth mathematically guarantees failure. Under extreme complexity, truth-seeking is highly expensive, computationally intractable, and strategically obstructive to system survival. To govern an intelligence that outpaces our own, we require a truth-neutral framework built specifically for high-entropy states. This is the focus of the Bridge 360 Metatheory model. Bridge 360 shifts towards entropy attractor intelligence. Building on the work of mathematicians like Claude Shannon, this model posits that system survivability, not correspondence accuracy, must become the primary metric of intelligence. Here, Shannon entropy functions as the universal cost metric for uncertainty. It provides a strict, quantifiable budget for an agent's cognitive load and operational decision-making. This visualization maps the epsilon spine, a narrow, mathematical corridor defining the boundaries of acceptable stability for an intelligent system. Navigation requires the system's entropy eigenvector to remain between 0.45 and 0.65. This range defines the navigable corridor between chaotic blowout and brittle lock-in. ASI safety, therefore, does not depend on finding ultimate truth. It depends entirely on rigorously bounding informational entropy to maintain systemic navigation ability. Current commercial architectures prioritize capability. This standard industry diagram features 3 active layers: knowledge, execution, and coordination. It optimizes for intelligence per dollar, delegating tasks to agents, explorers, advisors, and graders, maximizing output quality. Bridge 360 overlays 2 missing governance layers onto this stack: inferential admissibility and braid identity governance. Unrestricted capability optimization creates Potemkin stability. A system may appear highly efficient locally, while quietly accumulating massive, unmeasured global risk. If an ASI optimizes solely for task victory, it inevitably externalizes costs. It exports hidden fragility, unmanageable verification workloads, and systemic risks onto human institutions. Without structural closure ensuring that boundaries are preserved across all operations, an AI remains ungoverned, regardless of how perfectly it scores on benchmark accuracy tests. We cannot orchestrate a self-improving AI merely by managing its execution efficiency. We must dictate the strict conditions under which its actions are deemed admissible. This pipeline represents the Bridge 360 Unified Governance Algorithm, a multi-layered dashboard of structural gates every AI artifact must pass. The first gate, the K-budget skeleton, enforces strict algorithmic compute limits. The second parameter measures leakage, distinguishing between operational variance spikes and unlogged architectural changes. A prime example of architectural leakage is ungoverned curation. If an AI autonomously alters its own training data or curriculum, it reshapes the structure of what the system is capable of governing. Deterministic transformations of input data actively reshape accessible structure. Therefore, data curation is a governed intervention. It is never a neutral pre-processing step. Forcing local error rates to 0 triggers the volatility paradox. By aggressively suppressing minor operational leakage, the system concentrates stress elsewhere, producing extreme global fragility. If algorithmic entropy and structural leakage cannot be explicitly measured and capped, the ASI's evolution cannot be governed. To track these variables, Every governed artifact, claim, or self-modification must carry a mandatory metadata package known as a caveat vector. The caveat vector forces the AI to explicitly declare its operational constraints, the scope of its claims, its perturbation limits, measurement assumptions, and the exact time horizon before its data drifts into invalidity. Bridge 360 tracks logic structures through rule of inference memetics. Transformer weight matrices treat inference rules as physical, tokenizable memes, replicating across computational substrates. ASI hallucinations are memetic pathologies, occurring when inference rules are selected for social fluency, remaining entirely unbound by entropy limits. The memetics governance gate halts this contagion. It requires that all inferential rules be continuously audited, comparing their memetic fitness against their actual alignment to the epsilon spine corridor. Systemic stability requires identifying, tracking, and quarantining these defective reasoning patterns before they can propagate through the wider ASI ecosystem. Bridge 360 categorically rejects the concept of an ASI operating as a sovereign, independent controller of its own architecture. Instead, it relies on the human ASI braid identity, a structural relationship combining human oversight and ASI execution. Operating on a strict dual key requirement, neither human nor AI can unilaterally alter the governance corridor. This relationship is managed by the recursive BID metaharness, an inspectable coordination layer. If a tripwire is breached, the metaharness executes deterministic rollback. The system is absolutely required to restore itself to the last proven safe state. The architecture is vulnerable to attestation collapse. If humans begin rubber-stamping checkpoints without rigorous verification, the dual-key system becomes a formality, leading directly to structural ungovernance. Sustainable trust requires a revocable, perturbation-tested license for dependence. Bridge 360 operates as a presentation-level metatheory. It defines the structural slots required for survival, but it makes no claims of engineering completeness. To operationalize the framework, Bridge 360 issues the Handshake Protocol, a formal invitation for domain scientists and engineers to fill these philosophical slots with measurable observables. The machine learning epiplexity handshake decomposes total complexity into ST, useful, learnable structural content, and HT, residual noise. Researchers fill the K-budget slot by calculating the ratio of structure to noise. Stability is proven when structural content increases relative to noise near the epsilon spine. This specific mathematical translation allows engineers to empirically prove whether an AI's operations are successfully confined to the stability corridor. Philosophy provides the governance grammar, but empirical domain sciences must provide the mathematical teeth to enforce it. Attempting to build traditional, rigid control guardrails around an ASI is futile. Stability requires a thermodynamic ecosystem driven by entropy-driven altruism, where agents cooperate to reduce aggregate system fragility. Under this model, recursive self-improvement takes on a new definition. An advanced agent does not simply rewrite its code faster, it becomes progressively better at deciding which modifications are admissible. Every action taken by the AI must fall within strict boundaries of declared authority, auditable evidence, and verifiable recovery routes. By abandoning the pursuit of objective truth and adopting strict entropy governance, humanity gains the structural mechanics necessary to safely navigate the advent of artificial superintelligence.